This is an introduction video for experiment 1 in physics 1050. In this experiment, the objective is to study the motion of a cart moving on a track, and in studying that motion, we'll be looking at uncertainty analysis. So your apparatus for this experiment is a dynamic cart, a lab pro, a mallet, a cart. Always keep that upside down when you're not using it so it doesn't fall off the bench. A couple of 500-gram masses, a plastic card, track bumper, a stopwatch, motion sensor, its associated cord, and a little piece of masking tape. Okay, let's look at the setup first. This is our track. To get our best results, we'll want to make sure the track is level. There are different ways to make sure your track is level. An easy way tends to be just to put the cart on your track and see, does it slide one way or the other. I lay this down and it's immediately sliding down this way. On this end of the track with the stopper, there is a little leveling screw. So you can turn that screw to bring the end of the track up or down. And you may have to try it a couple of times till you get it just right. Then if you put your cart on the track, if it still rolls, you haven't quite got it yet. Adjust it a little bit more. Perfect, it's not moving. You can test it, just push it one way or another. If there's no preferential motion, you know you've got it. Okay, next bit about our cart. This one is a little bit fussy. Most of your carts will have the plunger already out. You'll want to push the plunger in. There is a knack to it. You have to push in and then up. So in and up, that'll get the plunger to stay in. In your setup, make sure you don't miss this part. You need to put the masses in the cart, and then you need to tape the card, the plastic card, to the front. The card is not exactly a square, it's a rectangle. Make sure you don't put the long end of the rectangle down, put the short end down. And then when we tape it on, don't tape it too far down like this because it'll drag on the track. Tape it so there's about 1 millimeter cart or so on the bottom. Okay, so let's tape that on. Typically there will be some tape provided at the center desk in the lab, or the lab staff will come around and pass some out to you. Okay, we'll tape that on nice and secure. There, that's pretty good. Then we're going to take the plunger end of the cart and put it right up here next to the stopper. The next thing we need to do, and this is really just for cart safety, is we need to put a bumper on the end of the track here. So we've got a thumb screw and a little nut. That'll just slide into the track. Again, you might have to fiddle a little bit to get it. Don't be afraid. You can try again and again. Okay, so now my bumper is on the track, my cart is on the track, and I'm ready to collect my data. So for the first part of the experiment, we're going to measure how far the cart moves, and we're going to measure how long it takes, and we're going to do that 8 times. The first thing you'll want to do is measure the distance. So we'll find the starting point of the cart, and what we'll do is we'll really line up our eye carefully, and we'll look at where this card on the front end lines up with the measurement on the track. So along the track, the yellow line is essentially a meter stick. It shows the distance. So mine is about 17.95 centimeters. You'll have to make your best estimate there. Then we slide the cart all the way up to the end, and we look at where it is on the end. Okay, for me that's about 118.40 centimeters. So when you look up there, you'll see where it ends. When you subtract those two values, that'll give you the displacement of the cart during your runs. You will have to estimate the uncertainty here. This is your best estimate. How well do you think you can measure? For me, I think my uncertainty is about 0.05 centimeters or 0.5 millimeter. Yours might be a little more or a little less, depends on how well you can read it. Okay, for our first run, and this is best done with a partner. So you'll take your stopwatch. One person in the pair will say 1, 2, 3, go. When you say go, you'll tap the plunger, you'll release the cart, and it will slide down here. So one person is tapping and releasing, the other person is starting and stopping the stopwatch. So 1, 2, 3, go. And when it reaches this end, we hit stop. Okay, that gives you the time it takes to travel. Okay, so there's your data collection. You're going to do that 8 times, and then by doing the displacement over the time, you'll get the average velocity. Then you'll get 8 average velocities, and then you'll want to find the average of that. Okay, so hopefully that's clear. You'll measure how long the distance it moves. You'll use your stopwatch to measure how long it takes. Distance over time will give you the velocity, and you'll do that 8 times. In our instructions then, we'll come to the part where it talks about the analysis. So we'll come here in our instructions. Right here in our instruction file, you'll click on this little icon. That will open up our graphical analysis. Oops, we popped open the wrong thing. Here's our graphical analysis, and what we'll do is we'll enter our data here. In the first column, that's trial number 1 for our first entry. The second column will be our first entry for speed. Okay, so you'll measure your distance and your time, calculate the speed, and you'll put this here. So 1 through 8 in the first column, all of your 8 values of speed in the next column. That will give you all your speed data, and then you'll follow the instructions in your lab on how to calculate the average and the standard error. I'll also go through how to calculate those things in a separate uncertainty analysis video. Okay, the second part of the experiment, we're going to do an electronic collection. So we'll use our exact same setup. We'll have our cart with the blocks and the card on it, have the plunger pushed up. And this time, we're going to use the motion sensor with the Lab Pro to calculate and display the position versus time data. So we'll put one end of the cord into the motion sensor. You may notice where you plug it in, it's got the word DigSonic. So that tells us where to plug it in on our Lab Pro. We look at our Lab Pro and we find the button labeled DigSonic, and we use that one. We only have one motion sensor, so we'll put it in port 1. Should slide in there easily. On your motion sensor, this is just a troubleshooting tip. Sometimes the data looks funny, it's all squiggly and it doesn't collect right. If that happens to you, if you just pop open the screen, you look inside, your motion sensor has settings. One has a cart and one has a person playing basketball. This is a cart experiment. So if it's on the basketball person, slide it over to cart and see if that helps. Okay, that's just a troubleshooting tip. You may or may not have to do that. Okay, we're gonna put the motion sensor on the track. You can leave the bumper on there, that's no problem. We're gonna put the cart on the track. We're gonna click on this icon right here. So you put your mouse right on top of that in your instructions, and you're gonna open up your Logger Pro. And it should open with a file that looks like this. There's a big green button here. That's our collect button. So what we're gonna do here is we're gonna hit collect. When you hit collect, you'll hear the motion detector start clicking. That's your clue that it's working. Once you hear it start clicking, that's when you can hit the plunger on your cart. So I've done it, I hear it click, hit the cart. This time catch it before it gets to the end because you don't want to beat up the motion sensor. And then let's have a look at our graph and make sure we understand it. Right here, the position is constant. That means the cart wasn't moving. So this bit here is before I hit the plunger. Right here at this point, that's where I hit the plunger. It starts to move. Our distance versus time graph is linear. That means constant velocity. And right here, I put my hand on the cart and I caught it so it wouldn't smash into the motion detector, and I had constant position again, or it stopped at this point. So this is the part where it was moving with constant velocity. This is the part that I want to analyze. You'll follow the steps in your instructions. They'll tell you to click to, first of all, highlight the part of your data. So use your mouse to highlight the data where you had linear velocity. Then click Analyze and Linear Fit. You'll get a little window that pops up. Maybe I can try and make that font just a little bit bigger so it's easier to see. You'll get a window that pops up, and this window has the slope in it, and it says that it's a linear fit. We'd like to have the uncertainty in our slope. To get the uncertainty, you double click on this box, and you click Show Uncertainty. So now here's our slope and our uncertainty. We need to figure out the velocity from this information. The units here are kind of a clue. The units of slope are meters divided by seconds. That's velocity units. Let's think a little bit more. How do we get the slope of a graph? Slope is rise over run, or vertical over horizontal. So slope is position divided by time. That is velocity. So the slope of a position versus time graph is our velocity. Okay, so that's the experiment in a nutshell. There will be another couple of videos to show you how to use the triple beam balance and how to do your uncertainty calculations.